Hi everyone, welcome to Learn with History YouTube channel. So in this video we'll be treating Jamb physics question for episode 1, which comprises 20 questions from question 1 to question 20. I want you guys to stay attentive. If you really want to score high in your Jamb exam, especially in physics, stay tuned. This question right here will really help you. So let's dive in. And if you are interested in tutorial, just share this number right here on WhatsApp to join the tutorial. And if you are interested in getting Jamb syllabus for free for any subject, including maths, chemistry, physics, just name it, just share this number right here. You get the Jamb syllabus for free. And if you are interested in past questions, just share this number right here to get it. And if you haven't subscribed to Learn with History YouTube channel, what are you waiting for? Hit that like button and subscribe now as we dive in. But before we dive in, don't forget to subscribe for those that have not subscribed. So once I drop the next episode, you will be the first person to watch this video. Let's continue. Question 1. A car starts from rest and moves with a uniform acceleration of 30 meters per second square for 20 seconds. Calculate the distance covered at the end of the motion. A 6 km, B 12 km, C 18 km, D 24 km. So we can't know our answer now except we solve this question. And before solving any question, we need to know the topic where it emanates from. The topic of this question, where this question is coming from, is motion. And we have 3 formulas to solve this question. Let me write it out. The first one is S equals half ut plus at square. The second one equals V equals u plus at. The third one is V square equals u square plus 2as. So this is the 3 formula. So let's write out our givens. We have our acceleration as 30 meters per second. Our givens. So our acceleration is 30 meters per second square, and our time is 20 seconds. So we are looking for our distance, which is represented as S. So if we check all the formula right here, the one that is suitable to solve the question is S equals half ut plus at square. The reason is because S is the subject of the formula here, and we are looking for S. And we also have our A, we have our T. So let's just solve it. And our U is 0 meters per second. The reason why our U is 0 is that the car is starting from rest. That's why our U, which is initial velocity, is 0. So let's solve. So our S equals half, our U is 0, multiplied by 0, multiplied by our T, which is 20, multiplied by, so plus, you see plus here, plus our acceleration, multiplied by our time. Don't forget to add this square. You now square it. So our time is having square. So you add the square to the 20. So half 0 multiplied by 20 is 0. So you don't have to input it. Plus 30 multiplied by 400. Multiplied by 400. I hope you understand. Half plus 30. 0 multiplied by 20 is 0. So there's no need of adding it. So, and 20 squared is 400. So S equals 2 divided by 30 will give us 15. So we are now left with 15 and 400. So 15 multiplied by 400 is 6,000. So we can't leave it like that. The unit of distance is meter. So we add the unit here. The unit of distance is meter. So we have 6,000 meters. So if we convert this 6,000 meters to kilometer, because our options are all in kilometer, to convert meter to kilometer, we divide by 1,000. And if we divide it by 1,000, we are left with 6. So it's now, so the correct answer is 6 kilometer. 6 kilometer. If I convert from meter to kilometer, you divide by 1,000. So if you check the option option A is the correct answer, which is 6 kilometers. Let's move to the next question. Question 2. A machine whose efficiency is 75% is used to lift a load of 1000 Newton. Calculate the effort put into the machine if it has VR of 4. What's VR? VR is the velocity ratio. So this is a simple machine question and this is a motion question. These two questions, Jamb repeat it every year. So be attentive. Let's start. Our efficiency is 75%. What next? Our load is 1000 Newton. Our effort is the small e. So the big E, the E in capital letter is the efficiency, while the small E is the effort. Our E is unknown. We are told to calculate our E. Our mechanical advantage is also unknown. Our VR, which is velocity ratio, is 4. So the formula for efficiency is MA over VR multiplied by 100. So jot this down. Just find a note to jot all this formula down. So when you forget any of it, you can quickly go and check your note. So we are looking for effort. We are looking for what? Effort. How do we get our effort? Before we can get the formula for mechanical advantage is load over effort. Load over effort. So we don't have our mechanical advantage and we don't have our effort. And we don't have our effort. So how do we get our effort? We are left with only load. We only know our load as 1000 Newton. So we cannot continue with this. We have to know our mechanical advantage using this, since we have our efficiency here and our VR, which is velocity ratio. So let's just input it. So our efficiency is 75 over 100. 75%, which is also 75 over 100. This 100 also represents it. So there's no need of adding this 100 again. It's already here. Multiply by MA over VR. We won't write VR here because our VR is 4. We just change it to 4. So if we cross multiply, MA, which is mechanical advantage, multiplied by 100 is 100 MA, which equals 75 multiplied by 4 is 300. You know, to know all these things of it. So when solving question, it will be easier to be solving it. So it won't take much time. So if we have to divide 100 by the both sides to get our mechanical advantage. 200 divided by 100 and 100 divided by 300 is 3. So our MA equals 3. So we already know our MA now. The next thing is to solve for our effort. Our MA is equals 3 equals our load is 1000 and our effort is unknown. We have our mechanical advantage as 3, our load 1000 and our effort is unknown. What do we do? Let's cross multiply. So let's bring it here. Our effort, 3 multiplied by our effort is 3 equals 1000. So let's divide both sides by 3. 3 cancel 3. So our effort equals 3 divided by 1000 is 333.33. 333.33 Newton. So that's the correct answer. And if you check our option, it's in option B. 333.33 Newton is the correct answer. Before we continue, make sure you have subscribed to Learn with Teacher YouTube channel as we move to the next one. Question 3. A quantity which requires magnitude and direction to be specified is A. Distance, B. Displacement, C. Mass, D. Temperature. So, mass is a scalar quantity, temperature is a scalar quantity, distance is a scalar quantity. The only vector quantity is displacement, which is the correct answer. It says which requires a quantity which requires magnitude and direction. Distance, mass, and temperature only requires magnitude and they have no direction. But the one that has the two is displacement, and that's the definition for vector quantity. While scalar only have magnitude but no directions. Question 4. Which of the following material is a conductor? A. Plastic, B. Sodium, C. Wax, D. Glass. So what's conductor? To be able to conduct heat and electricity. And if we check the option, the only one that can conduct heat and electricity is sodium, because sodium is a metal, and metal is a good conductor of heat and electricity. Question 5. Which of the following quantities has the same unit as watt? Which of the following quantity has the same unit as watt? A. Force times time, B. Force times distance, C. Force times acceleration, D. Force times velocity. Let's start from force times time. Force times time is the formula for impulse, which has nothing to do with watt. We all know that the unit for power is watt, and for force times distance, that's work, and the unit for work is joule. And for force times acceleration, it has nothing to do with watt. Also, force times velocity is the formula for power. It's another formula for power, and power, the unit of power is watt. Question 6. Which of the following is a pure semiconductor? A. Silicon, B. Phosphorus, C. Transistor, D. Carbon. So option A, which is silicon, is a pure semiconductor. Silicon and germanium is a pure semiconductor, or in the periodic table. So silicon is the correct answer. If you are watching this video up to this moment, please like, share and subscribe, and drop your comments in the comment section if you have any question to ask regarding this question. If you have anything to ask regarding this question, just drop it in the comment section as we move to the next one. Question 7. Transistors are used for the dash: A. Conversion of AC to DC, B. Conversion of DC to AC, C. Amplification of signals, D. Rectification of signals. Transistors amplify signals, and if we check the option, in option C, amplification of signals is there. So amplification of signals is the correct answer. Transistors are used for the amplification of signals, and for conversion of AC to DC, or to DC, or from DC to AC, it is the work of transformer. It is not the work of transistor. Let's continue. Question 8. The energy in the nucleus of atoms produce heat, which can be used to generate A. Mechanical energy, B. Electrical energy, C. Potential energy, D. Kinetic energy. Potential energy and kinetic energy are still under mechanical energy. For those that have not watched the video which I did on work, energy and power for physics, go and watch it out right now, so you can understand the concept which is in this question. So it is the one related with mechanical energy. So mechanical energy is the correct answer, not electrical, because both potential and kinetic are still under mechanical. Mechanical energy deals with heat. Question 9. Which of the following waves has the shortest wavelength? A. Radio waves, B. X-ray, C. Infrared, D. Ultraviolet. So guys, I'll be giving you an acronym to understand the concept of wavelength. You know this question is under electromagnetic waves. So let me write out the acronym. Gamma, extra, ultra in my radio. Gamma, extra, ultra in my radio. This is the gamma ray. This extra means X-ray. This ultra means ultraviolet. This in means infrared. This means microwave. Microwave is not in the option. And this radio means radio waves. So from here, if it goes up like this, it represents how the frequency increase, because gamma ray has the highest frequency while radio wave has the lowest frequency. But if it's going down like this, gamma ray has the lowest wavelength while radio wave has the highest wavelength. If it's going up, it increases the frequency, and if it's going down, it increases the wavelength. It increases the wavelength, while if it's going up, it increases the frequency. So if you have to check the shortest wavelength, you already know that if it's going down, it increases the wavelength. This is the highest wavelength. After that, microwave. After that, infrared. So infrared is not the shortest. We still have X-ray and radio wave left, and we still have ultraviolet. So ultra is the next, and after that we have our extra. So radio wave is the highest wavelength. So extra, which is also known as X-ray, is the lowest wavelength according to the option. But assuming we have gamma ray in the option, we have gone for gamma ray. I hope you understand now. Question 10. The process whereby a liquid turns spontaneously into vapor is called that. A. Evaporation. B. Regulation. C. Boiling. D. Sublimation. The correct answer is evaporation. Evaporation is the process of liquid to turn to vapor, which is gas. While regulation, some people will be saying what's regulation? Regulation, for those that don't know, regulation is the process of ice to melt under pressure. For ice to melt under pressure. That's the meaning of regulation. So if you haven't subscribed, please find a moment to subscribe now as we move to the next one. Question 11. If a sonometer has a fundamental frequency of 450 Hz, so this Hz is the unit of frequency. What is the frequency of the fifth overtone? A. 2700 Hz, B. 455 Hz, C. 442 Hz, D. 75 Hz. This is one of the questions that is very simple in physics, but some candidates miss it. So if you see this kind of question, the first thing to do is to note the overtone. It is fifth, so our fifth overtone equals 6 multiplied by the frequency. You multiply it by the fundamental frequency. So 6 multiplied by 450 is 2700 Hz. As you see, guys, very simple. Assuming we have sixth overtone here, what do? You just write sixth, and you multiply 7, which is the next value, by the fundamental frequency, and you get your answer. I hope you understand that now. And assuming the overtone here is 8, you have to multiply 9 by the fundamental frequency here. And if you check the option A is the correct answer. So if you have been finding this question difficult, I have made it simple for you guys. Question 12. Induced EMFs are best explained using A. Ohm's law, B. Faraday's law, C. Coulomb's law, D. Lenz's law. So Lenz's law deals with induced EMF. So the correct answer is Lenz's law. Lenz's law. Question 13. So this question is under angular velocity question. An object moves in a circular path of radius 0.5 meter with a speed, and speed is represented as v, which is velocity, 1 meter per second. What is the angular velocity? So the formula for angular velocity is W equals V over R. This is the angular velocity, this is the velocity, and this is the radian. Let's input the value. Our V is 1 and our radius is 0.5. So our angular velocity equals 1 divided by 0.5 is 2. You can't leave it like that. So angular velocity is measured in radians. So radians is the unit, 2 rads raised by -1. So if you check the option C is the correct answer. I want you to note this formula. Find a note where you be jotting your formula. So anyone you forget, you just check your note and easily remember it. It's very important. It's really helped me during my exam. Question 14. Clinical thermometers are examples of A. Pressure gas thermometers, B. Resistance thermometers, C. Alcohol thermometers, D. Mercury in glass thermometers. So the correct answer is mercury in glass thermometer. Clinical thermometers, which is being used in the hospital to measure the degree of hotness and coldness, is being used in the hospital to measure the degree of hotness and coldness of a body. So clinical thermometer are an example of mercury in glass thermometer. So let's move to the next one. Question 15. A car accelerates uniformly from rest at 3 meters per second square. Its velocity after traveling a distance of 24 meters is. So this is a motion. This is a question under motion. I discussed that we have three formulas for motion. Here I said S in question 1, where I discussed the three formula. So if you are very attentive, you should be able to solve this question yourself. So as I am solving mine, you're solving yours right there. So the formula, we are looking for our distance is known as 24 meter, and our acceleration is 3 meter per second square, because they say the car accelerates uniformly from rest. So we are looking for our velocity. Let me recap the formula I used earlier so you guys will be able to remember. I said S is equal to ut plus half at squared. This is the first one I wrote. The second one I wrote V is equal to u plus at. And the third one I wrote V squared equals u squared plus 2as. So if we check the givens, we have S, we have A, and we have V. The one that has S, A, and V is V squared is equal to u squared plus 2as. So that's the one that we are going to use. And we're also looking for our velocity. So our V squared equals u squared plus 2as. So our V squared is unknown. Our u is 0 because the question says a car accelerates uniformly from rest. So in your question, if you are not given your initial velocity, which is the u, and the question is stating that something is starting from rest, you should know it should be 0, because anything from rest is automatically 0. So our u square is 0, and our A, which is acceleration, is 3 meter. We've already written it here, and our S is 24. So let's input it. Our V square equals, our U square is 0 plus our 2 multiplied by our acceleration, which is 3, multiplied by our distance, which is 24. So our V square equals 0 plus 2 times 3 is 6, and 6 multiplied by 24 equals what? Equals 144. You need to know all this simple arithmetic. So you should be measuring in meter per second, but you can't stop there. You can't leave velocity with the square. So what do we do next? We square root it. If we square root it, square cancel this square root. So we are now left with our velocity. So the square root of 144 is 12. 12 meter per second is the correct answer. And if you check our option, it's in option D. 12 meter per second is the correct answer. Let's move to the next question. An object of mass 2 kg moves with a velocity of 10 meter per second. Our mass, the best thing to know is to write out our givens. Our mass is 2 kilogram, and our velocity is 10 meter per second, and our radius is 4 meter. So our centimeter force formula is mass times volume square, mass times velocity square over r. Don't forget to equate this square. If you leave this square and don't add it, there's no how you get the correct answer. So our centimeter force is, our mass is 2 multiplied by our velocity, which is 10 square, divided by our r, which is 4. So 10 square, you can just multiply 2 times 10, 20, and 20 square is 400. There's no how you get the correct answer. So 10 square is 100. 100 multiplied by 2 is 200. 200 divided by 4 is 4 divided by 20 is 5. So our answer is 50 Newton. And if you check the option, it's in option A. 50 Newton is the correct answer. Let's check question 17. A wave that travels through stretched string, like this, stretched string, is known as A, microwave, B, mechanical wave, C, seismic wave, D, electromagnetic wave. So the correct answer is mechanical wave. It travels through a stretched string. So if you have watched this video up to this moment and you haven't subscribed, what are you waiting for? Please subscribe now. Let's move to the next one. Question 18. A machine of velocity ratio 6 requires an effort of 400 Newton to raise a load of 800 Newton through 1 meter. Find the efficiency of the machine. So we have to find the efficiency of the machine. So guys, I'll be dropping a video on the topic simple machine. So this question, if you are not really understand simple machine, just subscribe to this channel now. So once I drop the video, you will be the first person to watch the video. So let's solve this question on simple machine. We are looking for our efficiency, and the formula for efficiency is MA over VR times 100. As I said earlier, because we've treated one question on simple machine earlier. So our effort is, which is the small is 400 Newton, and our load is 800 Newton. What other thing do we have? We already know our velocity ratio as 6. We are looking for our mechanical advantage. So the formula for mechanical advantage is L over E. To calculate efficiency, we need to know our mechanical advantage. So our load is 800 and our effort is 400. So 800 divided by 400 is 2. So our mechanical advantage is 2. So we can now proceed to solve. So our efficiency equals our MA, which is 2, over our VR, what's our VR 6, multiplied by 100. So 2 cancel 1, 2 cancel 2 will give us 1, 2 cancel 2 will give us 3. So we are now left with 100 all over 3. So 100 divided by 3 is 33.3, and efficiency is measured in percent, so we have 33.3%. And if we check the option, it's in option C, 33.3%. Let's move to question 19. The mechanism of heat transfer from one point to another through the vibration of the molecules of the medium is A. Convection, B. Conduction, C. Radiation, D. Diffusion. So conduction is the mechanism of heat transfer from one point to the other through the vibration of molecules of the medium. So conduction is the correct answer. Question 20, which is the last question for episode 1 on physics. During a thunderstorm, the sound is heard over a long time. The phenomenon is referred to as A. Refraction of sound, B. Reverberation, C. Superposition, D. Diffraction of sound. So once rain is falling and you are hearing that thunderstorm, and the thunderstorm is being heard for a long time, the sound of that thunderstorm, I hope you guys know it, everyone know the sound. That sound being heard for a long time, the phenomenon is reverberation. Question 21. The velocity v of a particle in a time t is given by the equation v equals 10 plus 2t squared. Find the instantaneous acceleration after 5 seconds. So think about it. So solve it. So guys, welcome to Learn with Israel YouTube channel. In this video, we'll be treating episode 2, which will be from question 21 to 40. And in the previous episode, which is episode 1, we've done question 1 to 20. If you haven't watched the video, go and watch it out now. So in this video, we'll be treating question 21 to 40 on episode 2, which is on Jamb. This is likely question. And if you are interested in Jamb tutorial, you can start this number right here to join the group. So guys, let's go back to the question. So we have to find the instantaneous acceleration after 5 seconds. The velocity v of a particle in a time t is given by the equation v. So v equals 10 plus 2t squared. Find the instantaneous acceleration after 5 seconds. So guys, let's solve. Our v equals 10 plus 2t squared. So we have to find our acceleration. And the formula for acceleration is change in velocity over change in time. So this dv represents change in velocity, and this dt represents change in time. So our change in velocity is 10 plus 2t squared. So our acceleration equals over our dt. So let's cross multiply. So if we cross multiply, we are left with a into t, change in time, a into t equals 10. 10 is equals to 0 in derivation. 10 is equal to 0. Why is it equal to 0? Because 10 is constant. It's constant in the question. So 10 equals to 0. So our 10 is 0 plus 2t squared. 2 square is 4. So we are now left with 4t. 4t. I hope you understand that now. 2 square is 4. Multiply by this t, it will give us 4t. So our a t equals was 0 plus 40 is also 40. So what's t? Our t is time. It says find the instantaneous acceleration after 5 seconds. So let's change our value. Let's input our value. The value for t is 5. So our a equals 5, 4 into 5. So let's multiply. 4 multiplied by 5 will give us 20. And the unit for acceleration is meter per second square. Don't forget, the unit for acceleration is meter per second square. So let's check our option. Yeah, you can find it in option B, 20 meter per second square. So let's move to the next question. Question 22. A motorcyclist traveling at 30 meters per second starts to apply his brakes when he is 50 meters from the traffic light that had just turned red. If he reached the traffic light, his deceleration is towards deceleration. Deceleration is going back. Why? Acceleration is moving forward. Moving forward. Deceleration is going back. For acceleration, you use plus. Why? For deceleration, you use minus. So the formula we'll be using. So before that, our velocity is represented as 30 meters per second. So our v, which is our given, our velocity 30 meters per second, and he said to apply his brakes when he's 50 meters. So that's our distance. Our distance is 50 meters. So what other thing do we have? We don't have any other thing. So let's solve. Our acceleration is unknown. So we have to look for our acceleration. So we'll be using v square equals u square minus 2as. Why are we using minus? We should be using plus, but why are we using minus? Because we have to solve for the deceleration. I explained that for deceleration is minus and for acceleration it is plus. So it's very important to note the question and to study it before answering it. So our v is 30 square equals our u is 0 square minus our, do you know why our initial velocity is 0? Because it says a motorcyclist traveling at 30 starting from rest, it starts. So our initial velocity is 0, while our final velocity is 30, it starts. Why? We have minus 2 multiplied by what's our acceleration? Our acceleration is unknown. Multiplied by our meter, and our meter is 50. Our meter is what? 50. So 30 square is 900. You can check your calculator. 30 multiplied by 30 is 900 equals 0 square is 0. So 0 minus 2 multiplied by 50a. Multiplied by 50a. So what is the next thing to do? 900 equals 0 minus 100a. 0 minus 100a. So we are now left with 900 equals minus 100a, because 0 minus 100 is minus 100. So don't forget to put this sign here. So let's divide by 100 to get our answer acceleration. To make our acceleration the subject of the formula. So let's divide. 100 divided by 900 is 9. And 100 divided by minus 100. So we are now left with 200 divided by minus 100, we are left with A, which is the acceleration. So our acceleration is minus 9 meter per second what? Square, because acceleration is measured in meter per second square. And don't forget to put this sign, because minus 100 divided by 900 will be left with minus 9 meter per second square. So let's check our option. Yeah, we can find that in option B, minus 9 meter per second square. And if you don't understand any of this question, make sure you rewatch it and make sure you understand it. So guys, let's move to the next one. Question 23. A car accelerates uniformly from rest at 4 meters per second square. How far will it travel in the fifth complete second? In what? In the fifth complete second. So if you check the question well, we have 2 seconds. We are having 2 time, and I will explain how. So let's write out our givens. Our acceleration is 4 meters per second square. What other thing do we have? Our initial velocity is 0. Why is it 0? Because it is starting from rest. And we also have our time. We have 2 time. The first one is 5 seconds and the second one is 4 seconds. How? The question says, how far will you travel in the fifth complete seconds? In the fifth complete second. So when solving this kind of question, you need to calculate for the fifth complete seconds and the one before the fifth complete second, which is the fourth second. That is how we can know the exact one for fifth second. We need to calculate for both fourth and fifth. So that's why we are having 2 time here, which is fifth and fourth second. So our formula will be different. And what are we looking for? We are looking for the distance, which is S. It says how far will you travel in the fifth complete second. Our distance, the formula we'll be using is half AT square minus half AT square. The reason is because our time, we have 2 time, which is the fifth and the fourth. So we need to calculate for fifth and fourth and now subtract it so we can get the distance. In this kind of question, when solving this kind of question, use this formula. Assuming we have 1 second, 1 time, which is assuming we are solving for 1 time assuming we are solving for 1 time, we would have gone for only this. But since we are having 2 time in the question, we'll be solving it like this. So our distance equals half multiplied by our A, which is acceleration, and our acceleration is 4, multiplied by time. Our time, let's solve for our first time, which is 5. Our first time is 5 seconds. So let's square it. Minus half multiplied by our acceleration is 4, multiplied by our time, which is 4 square. We can't use 5 because we are solving for the second time, which is 4. So let's solve. 1/2, 2 cancel 4, so we are left with 2. So we are now left with 2 multiplied by 5 square is 25, minus 2 cancel 4, we are left with 2. So 2 multiplied by 4 square. What's 4 square? 4 square is 16. So our distance equals 2 multiplied by 25 is 50. And 2 multiplied by 16 is 32. So let's subtract. So now let's subtract for the fifth seconds minus the fourth seconds, and so we can derive our distance. So 50 minus 32 is 18. We can't leave it like that. We need to add the unit, and the unit for distance is meter. Distance is measured in meter. So the correct answer is 18 meter. So let's check our option. Yeah, we can find that in option A. 18 meter is the correct answer. So let's move to the next question. Question 24. A motor vehicle is brought to rest. Is brought to what? Is brought to rest. Note that. From a speed of 15 meters per second. So this is our final velocity, which is V, and this is our initial velocity, which is at rest, which is U. and our initial velocity is always 0 if it is starting from rest. So our time is 20 seconds. So let's write out our givens. Our u is 0 meter per second, and our v, which is final velocity, is 15 meter per second, and our t, which is time, is 20 seconds. 20 seconds. So how do we solve? The formula we'll be using for, it says calculate the retardation. The formula we'll be using is acceleration equals v minus u over t. When calculating for retardation, this is the formula you are going to use. Calculating for retardation also means we are looking for our acceleration, and to get the acceleration you need to minus the final velocity from the initial velocity and divide it by your time. So our acceleration equals, our final velocity is 15 minus our initial velocity is 0 divided by our time, which is 20 seconds. So our A equals 15 minus 0 is 15, and we are now left with 20. So 15 divided by 20 is, so check your calculator, 15 divided by 20 is 0.75. Can't leave it like that. I hope you know. Acceleration is measured in what? It's measured in meter per second square. It is measured in meter per second square. So our answer is 0.75 meter per second square. So let's check the option. You can find it in option C. 0.75 meter per second square is the correct answer. So guys, let's move to the next one. Question 25. Capacitors are used in the induction coil to dash: A. Control circuit, B. Dissipate energy, C. Prevent electric spark, D. Prevent distortion. So capacitors are being used in the transformer in order to prevent electric sparks. It is being used in order to prevent electric spark. So option C is the correct answer. Question 26. The uses of lenses is not applicable in the A. Projector, B. Human eye, C. Periscope, D. Telescope. So let's start from projector. The uses of lenses is applicable to projector and in the convex lenses. Convex lenses for projector. For human eye, it is also convex lenses. The use of lens, it is applicable for the human eye. And for periscope, no. The use of lenses is not applicable in the periscope. Periscope is used to focus and observe image. Periscope is used to focus or transmit images. It helps in transmitting image. And for telescope is also the uses of lenses is also applicable to telescope, and it is in convex lens times 2. The telescope needs convex 2 times convex lens of the human eye or the projector. And the human eye we use maybe one, but the one for telescope we have to double, because telescope is used for viewing stars. It's used for viewing far images like star. So it has to double. Question 27. The pair of physical quantities that are scalar only are: A. Volume and area, B. Moment and momentum, C. Length and displacement, D. Impulse and time. So the pair, so what's scalar? Scalar is the one that has only magnitude but no direction. So we also have vector, and vector has both magnitude and direction, while scalar have only magnitude but no direction. So volume has only scalar. I'll be representing it as S, while area has only scalar. It has only magnitude but no direction. While moment has vector, it has both magnitude and direction, and momentum has vector. Momentum has both magnitude and direction also. For length has only scalar. Length has only magnitude but no direction. while displacement is vector quantity. Displacement has both magnitude and direction. And for impulse is a vector quantity. Impulse has both magnitude and direction, while time is scalar quantity. Time has only magnitude but no direction. So we have to check for the pair of physical quantity that are scalar only. That are what? That are scalar only. So let's start from option D. Both impulse and time are not scalar. Impulse is vector while time is scalar. So option D is wrong. Option C, length and displacement. Length is scalar while displacement is vector. So option C is wrong. We are looking for the one that has both scalar. For option B, moment and momentum is both, the two are vector quantity. So it's also wrong. The correct answer is option A. Volume and area are both scalar only. Volume and area is the correct answer. Question 28. The instrument used to view stars is the dash. A. Prism, binoculars. B. Telescope. C. Film projector. D. Microscope. I explained earlier that the instrument for viewing star is telescope. Telescope is the one used for viewing star. With the help of convex lens, it is used for viewing star. So telescope is the correct answer. And for microscope, we all know microscope. Microscope is the instrument used for viewing tiny images that naked eye can barely see, or that is too small for naked eye to see. Microscope is used for viewing that kind of image. So guys, let's move to the next one. And if you are watching and you haven't subscribed, please subscribe now as we move to the next one. Question 29. When the human eye loses its power of accommodation, the defect is known as A. Astigmatism, B. Long-sightedness, C. Short-sightedness, D. Presbyopia. So guys, let's start from astigmatism. So astigmatism is a defect of the eye in which the individual or the person will not be able to see clearly. The vision will be very blurry, and it is corrected by cylindrical lens. It is corrected by cylindrical lenses. And for long-sightedness, another name for long-sightedness is hypermetropia. And it is being corrected by convex lens. So another name for short-sightedness is myopia. And for presbyopia is a defect of the eye, and it occurs when the eye is aging. When an individual is getting to a certain age, the eye will begin to age, and this is when the presbyopia occurs. And this presbyopia is the ability of the eye to lose focus on the distant object and the near object. So the question says, when the human eye loses the power of accommodation, what is the power of accommodation? The power of accommodation is to be able to see distant objects. When I say distant object, I mean far object. And when the eye is able to see near objects, when the eye is able to see both near and far, that is the power of accommodation. And when the eye loses the power of accommodation, the terminology is presbyopia. Presbyopia is when the human eye loses the power of accommodation, when the eye begins to age. That is when the ciliary muscle begin to weaken. So let's move to the next one. Question 30. The heat required to raise a mass of a substance through 1 K is known as, this 1 K means 1 Kelvin. Through 1 Kelvin is known as A. Specific heat capacity, B. Specific latent heat of vapor, C. Capacity latent heat of fusion, D. Heat capacity. So specific heat capacity is the heat required to raise a mass of a substance through 1K. That is the specific heat capacity. Let's move to the next question. Which of the following is a secondary color? A blue, B orange, C red, D green. So let's start from green. Green is a primary color. Green is a primary color. And for red, red is a primary color. Red is a primary color, while orange is a secondary color, and blue is also a primary color. So you can be able to differentiate the four color, one that is primary and the one that is secondary. So the only secondary in the option is orange. Orange. Question 32. Which of the following is used for the correction of short-sightedness? A. Concave lens, B. Concave mirror, C. Convex mirror, D. Convex lens. So for the correction of short-sightedness, the concave lens is the correction of short-sightedness. While for convex lens is used for the correction of long-sightedness, as I mentioned earlier here. So guys, if you haven't subscribed or you are a new viewer just watching this video and you haven't subscribed, please subscribe now and make sure you drop a comment in the comment section. If you have any question to ask pertaining this video or anything to ask me, just feel free and drop your question in the comment section. I'll make sure I reply you. Just drop it, I'll make sure I reply you. And make sure you share this video. Share it to your WhatsApp status, share it to your Facebook, share it to anywhere you can share it to, and make sure you share it to your friend, especially your friends that are in need of this video. Don't be selfish. This video is really helping you, which I know. Make sure you share this video to your friends and even especially your classmates also that are in need of this video. So guys, let's move to the next one. Question 33. A train with an initial velocity of 20 meters per second is subjected to a uniform deceleration of 2 meters per second square. The time required to bring the train to a complete halt is, so let's solve. A 40 seconds, B 10 seconds, C 20 seconds, D 5 seconds. We need to solve before we can know our answer. So the formula for acceleration is V minus U over T. As I said earlier, we have to minus our final velocity from our initial velocity divided by our time to get our acceleration. Okay, let's solve. Our acceleration is 2 meters per second square equals, acceleration is also equals to deceleration. It's just that acceleration is plus while deceleration is minus. So our deceleration is 2 meters per second square. Our velocity is, our initial velocity is 0 and our final velocity is 20. So our initial velocity is 0 divided by our time. We are looking for our time. They say the time required to bring the train to a complete halt is, what is the meaning of complete halt? Complete halt is means complete stop. When the train is going to, when the time to required to bring the train to a complete stop. So what are we going to do? We are going to interchange. We are going to bring our acceleration here and make our time the subject of the formula, or we interchange. How do we interchange? By making t, by bringing t and bringing acceleration here. So t equals 20 minus 0 over 2. So our t equals 20 minus 0 is 20 divided by 2. So 2 divided by 20 is 10 seconds. 10 seconds. And another method we can use is by cross multiplying. If we cross multiply, we will now be left with 2t equals 20. 2t equals 20. So we now divide both sides by 2. 2 cancel 2. We are now left with 10. 10 seconds. Using 2 formula, getting the same answer is what learn with Israel do. We do this for fun. So if you also want to do this for fun, stay tuned and let's do this together. And if you check the option B is the correct answer, which is 10 seconds. So let's move to question 34. The wavelength of a wave traveling with a velocity of 420 meters per second is 42 meters. What is the period? What is the period? So this question is under wave. It's under wave. And how do we solve it? Our period, the formula period is represented as T, and the formula for period is 1 over F. What's the meaning of this F? This F stands for frequency, and the formula for frequency equals V over lambda. V over lambda. This lambda represents what? It represents the wavelength, while this V represents the wave speed, and this wave speed is also the velocity. Don't misinterpret this. This V represents the wave speed and it also represents the velocity. So let's solve. We are looking for our period, but we don't know our frequency. So how do? We have to first get our frequency by using this formula. So how do we do that? Our V, which our velocity is 420 meters per second, divided by our wavelength, which is also known as our wave speed, which is 42 meters. 42 meters. So guys, let's divide it. 42 divided by 420 will give us 10 meters per second. You can check your calculator to convert that, but it is wrong to leave it at 10 meters per second. Do you know why? Because frequency is measured in hertz. It's measured in hertz. Hertz is written as Hz. Hz. I want you guys to note all this unit. It is very, very important. So guys, let's now solve for period, since we have our frequency now. So our period equals 1 all over F, which is the frequency. So our frequency is represented as 10. So our period equals 1 divided by 10 will give us 0.1 what? Seconds, because time is measured in seconds. And if we check our option, you can find that in option B. 0.1 seconds is the correct answer. So guys, let's move to the next one. Question 35. Which of the following is not a vector quantity? A. Altitude. B. Acceleration. C. Displacement. D. Weight. So let's start from weight. Weight is a vector quantity. It has both magnitude and direction. And for displacement, as I mentioned earlier, displacement also is a vector quantity. It has both magnitude and direction. And for acceleration is also a vector quantity. And for altitude is a scalar quantity. It has only what? Only magnitude and no direction. Question 36. The ability of the human eye to focus objects on the retina is referred to as the power of what? A. Interference. B. Diffraction. C. Accommodation. D. Superposition. I remembered in this video earlier, I mentioned when treating question earlier, I talked about the power of accommodation to accommodate what is near and what is distant. And you can see that is what we are treating here. So the ability of human eye to focus objects on the retina is referred to as the power of what? The power of accommodation. Question 37. A manometer is an instrument used for measuring A. Relative density of liquid. B. Pressure in liquid and gases. C. Humidity. D. Atmospheric pressure. So guys, a manometer is an instrument used for measuring pressure in liquid and pressure in gases. So let's check. Yeah, it's in option B. Pressure in liquid and gases. A manometer is an instrument used for measuring pressure in liquid and gases. And for humidity, relative hygrometer is used for measuring humidity. So guys, let's check question 38. Which of the following obeys Ohm's law? A. Electrolyte. B. Metals. C. Diode. D. Glass. So out of the option, it is only metals that obey Ohm's law. The current passing through a metal conductor, it is directly proportional to the potential difference, also known as voltage. Also known as what? Voltage. And the formula for Ohm's law is IV. IV. And this is the current which is passing through the metal and directly proportional to the V, which is the voltage, which is also known as the potential difference. I hope you understand that now. It is the metals that obeys Ohm's law. So guys, let's continue. Question 39. Which of the following is the dimension of pressure? A. ml raised to power minus 1 t raised to power minus 2. B. ml t raised to power minus 2. C. ml raised to power 2 t raised to power minus 3. D. ml raised to power minus 3. So guys, before we do anything, we need to know the formula for pressure. Guys, what's the formula for pressure? I hope you are solving this question as I am also solving. So keep solving and make sure you drop your answer in the comment section for this particular question. Jamb always repeat this question every year. Don't treat this question lightly. Take it seriously. Take it what? Take it seriously. So the formula for pressure is force all over area. Force all over area. And the formula for force is mass times acceleration. Mass times acceleration. It is mass times acceleration, and the mass times acceleration, mass is represented as m, multiplied by our acceleration is represented as lt. Lt minus 2. Lt minus 2. So our acceleration is change in velocity over change in time. So that's how we get this Lt minus 2. So guys, let's multiply. So m multiplied by Lt raised to power minus 2, that's mlt minus 2. So that's our force. Our force is mlt minus 2. So let's bring it back here. So our area is represented as length times length. So our force is mlt minus 2. We have one invisible one here, and we also have one invisible one here. You all know that. So our area is length times length. So that will be L2. Let's represent it as L squared. So our pressure equals ML1 minus, let's take our L2 up here. So let's represent it as 2. Let's take our L up there. So we have 2. T minus 2. So our pressure equals ML. 1 minus 2 will give us minus 1. T minus 2. So the correct answer is ML minus 1, T minus 2. And if we check the option, we can find it in option A. ML minus 1, T minus 2. If you need more understanding on this particular question, go and check the video I made on units and measurements under my YouTube channel. Check the video I made on units and measurements. You will have a better understanding on the dimension. So let's move to the last question under episode 2. A radioactive isotope has a decay constant of 10 raised to the power minus 6 seconds per second. Calculate the half-life. Calculate the half-life. So the formula for half-life is T half equals 0.693 over decay constant. So the decay constant is represented like this. Our T half, which is also the half-life, equals 0.693. So what's our decay constant in the option? In the question, our decay constant is 10 raised to the power minus 6. So let's input it here. 10 raised to the power minus 6. So our half-life equals what? It equals 0.693 all over 10 raised to the power minus 6. So let's change this to standard form. We now have T half, which is half-life, equals 6.93 multiplied by 10 raised to the power 1. I hope you understand this simple math. 6.93 raised to power 10 multiplied by 10 raised to power 1 over 10 raised to power minus 6. So guys, let's bring it here. We now have t equals 6.93 multiplied by 10 raised to power minus 10 raised to power 1 over 10 raised to power minus 6. So let's bring it here. Let's bring minus 6 here. So we are now left with t half equals 6.93 multiplied by 10 raised to power 1 minus 6. So t half, which is half life, equals 6.93 multiplied by 10 raised to power minus 5. 1 minus 6 is 5. There's no need of taking 10 off there since we already have our 10 here represented here. So we just take only minus 6 and minus it from the 1 here and get minus 5. And if we check our option, we can find it in what? Wait. Oh, there is a mistake. What's that mistake? Since we can't find this in the option, what's the mistake? Check it well. We can find the mistake here. What's the mistake? Who can guess the mistake right? The mistake is that when we take minus 6 here, it returns to what? It returns to plus. That's the mistake. So let's change this minus to plus. 1 plus 6 is 7. 1 plus, when minus 6 go there, it turns to plus. So 1 plus 6 is 7. So we are now left with 6.93 times 10 raised to power 7. Note this, guys. If you get your answer and you solve it correctly and get your answer, and you are realizing that the answer is not in the option, calm down and go through it. You know, when I go through the solvings, I realize that there is a little mistake here. That's why the answer is not correct, and I corrected it. So instead of cleaning it up and starting all over again, just check well and correct your simple mistake that you made. So, and if we check the option, we can find it in option B. 6.93 times 10 raised to power 7 seconds. So guys, we've come to the end of this video. If you find this video helpful, please like, share to your friend and classmates and your WhatsApp status, and share it to anywhere you can share it to. Share it to everyone that you know that is in need of this kind of video. Don't be selfish. And so guys, we've treated episode 2. And if you haven't watched episode 1, make sure you watch that video. There is a lot for you there to gain. And in the next video, we will be treating episode 3, which will be from question 41 to 60. See you guys in the next one.